Doing the math over here, and this is the 2020 SMT discrete section problem number 3. Here's a view of this problem. Let A of n equal the summation from I equals 1 to n of the ceiling of n over I, and B of n equal to the summation from I equals 1 to n of the floor of n over I. Compute A of 2020 minus B of 2020. Okay, so the first thing I want to do here is maybe undo the summation notation and try to make more sense of this problem. Doing so gives us A of 2020 is equal to 2020, n is 2020, so 2020 over 1 plus 2020 over 2 plus so on and so forth until 2020, 2019, and then 2020, 2020. Okay, and then B of 2020 is going to be the floor of 2020 over 1 plus 2020 2 up till 2020, 2019, (2020, 2020). Okay, so now after this is all written, we want to ultimately subtract these two. So let's think of what the floor and ceiling function first of all do. Well, the floor and ceiling functions both return integers, right? So when is the floor and ceiling function going to be equal? Well, when we're taking the floor and ceiling function of an integer, we're going to get the exact same result. So basically, when we do subtraction, and in somewhere in this expansion, we get an integer. When we subtract, that's basically going to go to 0. So, and then we can easily get a hold of those, since we know that any divisor of 2020 in this expression will evaluate to an integer. And once we do the subtraction, they'll go away. So we know automatically that all the divisors of 2020 here will go away with one of these. Alright, next, let's think about any other number. So let's say we have 2020 and 7, which 7 is obviously not a divisor of 2020. The ceiling function will return the integer just above 2020 over 7, and the floor function will return the integer just below 2020 over 7. So in total, the floor and ceiling function will differ by 1. Therefore, when we do the subtraction, for every denominator that's not a divisor of 2020, we're going to have a net gain of 1, net gain of 1 for our expression. So with that in mind, let's proceed. So first, let's find the number of divisors of 2020. To do that, we need to prime factorize 2020. 2020, let's see, 5 goes into it, and then from 5 we have 404. Yeah, 404. And then 404 is 101 times 2 squared, so it's 2 squared times 5 times 101. Okay, from this we have 2 plus 1 is 3, 3 times 2 times 2, we have 12 divisors. So for 12 of these denominators, we're going to pair these, and once we do the subtraction, it's going to go to 0. For any other of these, the ceiling function is going to be exactly 1 greater than the corresponding floor function. Therefore, we have a net gain of 2020, because there are 2020 terms in this, minus the 12, which go to 0, for a final answer of 2008. And we are done.